This presentation explains Credible Open Knowledge Network, a project in the National Science Foundation's Convergence Accelerator program. Good data enables good insights, and good insights promote good decision-making. The open knowledge networks created by the Convergence Accelerator project are a public knowledge infrastructure. It will revolutionize intelligent decision-making in many areas. But imagine a world where data are riddled with inaccurate and misinformation. Unfortunately, this world is real, as there are many examples of how poor data leads to poor insights and disastrous decisions. We are building frameworks and tools to assist software developers and domain experts to ensure the credibility of their decision-making software powered by the open knowledge networks. To achieve this, we provide tools to improve objective credibility or accuracy of information, but we also take it one step further towards subjective credibility to ensure the decisions are contextualized or meaningful to decision makers. Let me illustrate an important use case of our project: vaccine misinformation. Many parents refuse or delay vaccines for children due to misinformation. This has led to completely preventable disease outbreaks such as measles. With 1 in 10 infants unvaccinated in 2016, the World Health Organization listed vaccine hesitancy as a top 10 threat to global health. Our healthcare workers need help. Today, if you bring your kids in for a checkup, you are given brochures called vaccine information statements from the CDC. While this information is accurate, our Phase 1 interviews with doctors and nurses told us these brochures help very little. They often do not address the parents' specific concerns. Some are worried about autism. The brochure doesn't even mention it. Depending on the parent's background, the statement's language and style may be unappealing or confusing. And for folks that don't trust the government, no statement from the CDC will help. So what should we do? The insight from our interviews was that the brochure must be contextualized for it to have a better chance of being perceived as relevant or credible. However, without the tools that we are creating, this simple insight is difficult to carry out in real time and at scale. Therefore, with collaborators at Duke University Health System, we are building an app to help healthcare workers. Imagine you are a nurse speaking with a hesitant parent. Quickly, you can punch in the parent's concerns and get key points you can make. Based on the parent's relevant context information from electronic medical records, the app automatically recommends personalized interventions. For example, if a parent is worried about autism and doesn't trust mainstream media, the app could recommend a video featuring a pro-vaccine mother of a child with autism. On the other hand, if a parent has read specific research connecting vaccines and autism, the app would suggest articles exposing bad research and retracted publications. For a second application, consider cybersecurity. We interviewed several security solution providers to understand how they address software and hardware vulnerabilities. The standard practice is to provide a list of vulnerabilities reported by various sources, ranked by their potential risks. Then, given limited resources, an analyst would prioritize fixing top-scored problems within an organization. This is the scenario informed by our partner, Fortified Logic, a security solution startup for power grids. But the one-size-fits-all risk scores ignore the organization's particular context. For instance, a vulnerability may pose high risk because attackers can exploit it over the internet. But in a power grid, a device with this vulnerability may not even be connected online. Without this context, overacting or overlooking something can lead to severe financial and even human loss, such as an unnecessary shutdown of a power grid. To solve the problem, we are building a tool to identify credible threats and prioritize resources according to each organization's unique context. It will be tested and deployed by our partners Fortified Logic and Siemens. Based on an organization's system deployment profile, this tool can provide customized prioritization and explanations of credible threats. Drawing insights from these applications, we are developing a framework of credibility and tools that will be important across domains. First, it will improve objective credibility, which is about fact accuracy. We will develop veracity tools for fixing bad data, and we will develop data provenance tools that explain query results and analytics results. But as we argued, credibility is far beyond data accuracy. Our framework will also improve subjective credibility, which is about perceptions that make information convincing to recipients. We will develop strategies to contextualize results from queries and analytics according to information recipients' needs and profiles, and we will develop communication strategies to present such results in a way likely to be judged credible. Under the hood, the key behind contextualization is a more holistic approach to capture knowledge. Beyond facts, we also track inaccurate information and its source, as well as relationships among various knowledge objects. We also capture user profiles that provide additional context. In between, we create a taxonomy that semantically connects the knowledge graph and user profiles. Then, we can contextualize by selecting the knowledge objects that match the users for maximum subjective credibility. For different applications, the knowledge graphs, user profiles, and taxonomies will differ, but the overall framework and techniques remain the same. We already developed a taxonomy and knowledge graph for vaccine misinformation, as well as a knowledge graph of 2,000 security vulnerabilities. In Phase 2 of the project, we'll have 3 types of deliverables. First, the cross-cutting framework and tools for assisting software developers. Second, the domain-specific credible knowledge graphs. Third, the systems for credible decision-making. The 2 systems we explained are for healthcare and cybersecurity professionals. We've also prototyped 2 other tools for the public, using another knowledge graph we developed for COVID-19 misinformation. One is a browser plugin that flags health misinformation on web pages using browsing history for contextualization. To create real-world impact, we'll work with our partners, including Duke Health, Fortified, Siemens, and fact-checking startups MetaFact and FactMata. We are collaborating with a few other teams to apply our technology to ensure the credibility of their solutions. We also expect to benefit from their unique data and services. Our interdisciplinary team is well prepared for the convergence research. The team has leading computer scientists, renowned social scientists, and application domain experts and partners. In addition to academics, our team includes researchers from the Army Research Lab, Qatar Computing Research Institute, Amazon, Google, and IBM. The team's work will be guided by a rigorous timeline and task assignment plan. Our journey will not stop when the Phase 2 grant ends. Instead, we'll work to sustain the open knowledge networks by continuing to engage a community of stakeholders and pursuing other funding opportunities. Our current plan is to open source this project data and technology. Should opportunities arise together with new development, we will also consider licensing or commercializing intellectual properties. Our technologies will also be key to sustaining the whole of Track A, since our team is unique in bringing the general credibility support for open knowledge networks. It will not only help other Track A teams, but also make open knowledge networks useful to the American people. Without these tools, we risk ending up at square one, with low-quality data and poor insights to drive decisions.